I'm going to mute everybody. And let me just unmute Jason here before I forget. Okay. So this is the Tech Dive webinar series, and we meet every month, and we meet on the second Thursday at 3 p.m. And this is our website here that we're looking at, and we have everything recorded. We're recording today. And as you can tell, we've been on a little bit of a Jupyter Hub, Jupyter Lab oriented kind of binge here. And today we're pleased to have Jason Grout, who you might think, why is somebody from Bloomberg speaking to a bunch of geoscientists? But he's going to be talking about some really cool stuff that can be used by lots of different communities within the Jupyter environment, namely the Jupyter Widgets. So Jason, I'm just going to, actually, do you want to pop your webcam real briefly just so we can see you out there in sunny California? There he is.
It's a little bit cloudy today, but it's good.
Looks like a cubicle. No. All right. So thanks. I'm going to make you the presenter now, and
great.
You should be able to share your screen momentarily. And
all right, I'm going to try just sharing Chrome and see how that works. If it doesn't work out, then I'll share my full screen.
All right, and you can pop your webcam off if you want, just so we get a little more real estate.
Sure. Maybe I'll introduce myself just a little bit and then pop it off.
Sure.
Are we ready?
Yeah.
Okay. Hi, my name is Jason Grout. I've been working at Bloomberg for the last couple of years, and I've had the good fortune of being able to work a lot with the open source community, particularly the Jupyter project, and in particular, working a lot on the ipywidgets and Jupyter Lab projects. But before I was at Bloomberg, I taught math at a university in Iowa, so I do have some academic leanings as well. And I'm excited to talk about the Jupyter Widgets project in particular, and some of the interesting things that people are doing with it, and I hope you find it useful. So I'm going to turn off my webcam and switch to the browser. So what we see here is the opening page to the documentation for Jupyter Widgets. It's formerly called the ipywidgets project when it was specific to IPython, but now it's more general, and we see implementations of Jupyter Widgets starting to come into other language kernels as well, besides Python. So R and other kernels are starting to be able to take advantage of some of these capabilities. If you go to the documentation, you'll see a number of pages that go through what the widgets are, what the widgets do, how to work with them, etc. Each of these pages is actually a notebook in the Jupyter Widgets repo, and we'll be working through some of these notebooks today, and I'll be talking through them, and then I'll have some examples to show a little bit later on. We'll be starting out in the classic Jupyter notebook, and then later on we'll switch to Jupyter Lab. I think we had a presentation here a couple months ago about Jupyter Lab. Jupyter Widgets work fine in Jupyter Lab, and there's some interesting capabilities actually that just came out this morning. We'll talk about that later. So to start off with, here's the basic introductory page to the documentation as a notebook. And we'll take a look at our introduction to Jupyter Widgets. For a lot of people is through the interact function. So let me just evaluate some cells here. A lot of times, of course, we have functions, they return values, and we want to be able to compute these values. So for example, this function just returns the parameter. In fact, we can make it even a little more interesting by returning x times x. And in a normal workflow, if you're trying to explore the parameter space, you might type a function, you might type, call the function again for different parameters, and you see different outputs, and you can explore your parameter space, you can explore the problem that you're trying to solve. But this actually is pretty slow, clicking in and changing some text and reevaluating a cell. And it requires some level of sophistication, at least not being scared from being able to edit code. And one of the purposes for the interact is make it very easy to change parameters in a function and quickly see the outputs. You can also notice that the slowest thing here is me editing the function, me editing the code and running it. So if instead we use the ipywidgets, the Jupyter Widgets interact function, let me evaluate this cell. What it does is it investigates the function, inspects the function, finds the parameters, and for each parameter you give it a hint about what kinds of values. Here I give it a number, so it's assuming that we want a slider to vary this number. And as I vary the number, as I vary the input parameter, the functions automatically run every time that input parameter changes, and you can see the output here. And so it's very easy now to scroll through my parameter space and see this function executed every time I change the parameter and see the output. I don't have to edit the code. I don't have to find where in the code to edit things. All I do is scroll a slider. Very simple, very easy, very quick to use. I'm going to return this back to just a single value.
Hey, Jason, could you just do a control plus like one time just to make it a little bit? Okay.
Is that any better?
Yeah, that's a little nicer. Thanks.
I can even go a little bit bigger
maybe
if you need.
Maybe one more.
All right. Is that better?
Yeah.
Okay. So again, evaluating this interact, inspects the function, finds the parameters, you give it some hint about what kinds of values the parameters are expecting, and it automatically creates some controls that you can interactively change each time you modify the control value. The functions rerun, the outputs reset up here. And it's not just numbers. If you say that parameter can be true or false, a Boolean, then it automatically constructs a checkbox. Or if you pass in a string, it automatically constructs a text box. And again, as I change the value inside the text box, the functions rerun for every change, and I have the output that is displayed down here. Again, simple concept, but extremely powerful, and can make your workflow very fluid. We can also use it as a decorator. You notice the first value of the interact function was the actual function. That's this pattern that we have for decorators. So if you want to define your function, like we have here, and in the decorator pass your hints about what kinds of controls it should display for each value. Again, the interact can inspect the function, create a list of controls based on your hints, and run the function for every time the parameters are changed. Sometimes you have a function, an existing function, and you only want to change one of the parameters. And in that case, we have you covered. We have a special fixed hint that says Q is always going to be 20, but let P be a number, and it automatically creates a slider. We try to be intelligent about the hints, about what kinds of hints you give us compared to what kind of controls you give us. But if you want to have more manual control, you can actually construct the actual control that is to be used. So in this case, I'm interacting with the function f, and I want x to be represented by what's called an int slider. I give it a minimum, a maximum, a step, a default value, etc. And I can have much finer grained control over the actual widget, the actual control that's put up in front of the function. Here's some hints about. Yeah, let me collapse GoToMeeting so I can have a little more room here. Here's how the hints are interpreted. If you have a Boolean, we give you a checkbox. If you have a string, we give you a text box. If you have a value or a tuple, a min, a max, or a tuple, a min, max, and step, then it's either an integer or a float, depending on if that value was an integer or float. And if you give us just a list of values, then we'll give you a dropdown. So for example, here is a slider that goes between 0 and 4. Here's a slider that goes between 0 and 8, but steps by 2. Here's a float slider, goes between 0 and 10, or between 0 and 2 with a step size of 0.01. And if you specify a default value inside the function, then that's used for a default value for the control. So here the default value of 5.5 is the default value of the control. If you need something like a drop-down to select from a range of choices, then just give it a list with the options as strings. And what this is doing, again, is calling the function with that string. Or if you want a function to be called with actual Python objects, you can specify a list of tuples. The first value in each tuple is the label. The second value is the actual thing that's passed into my function. So here, what's displayed is the labels for each value, 1 and 2. And what's actually passed into the function is the corresponding value, 10 or 20. And you can see that here.
Is that supposed to be a drop down when you click on those? I'm not seeing the drop down, but
it's probably because of the way GoToMeeting is capturing my screen. Yes, it's a standard drop down control that you'll see. So my guess is the pop-up window that's actually showing me the options is not being captured by GoToMeeting.
Huh. Interesting. Okay. Thanks.
Yep. But it is a standard select drop down. We have a little bit more control as well if you want some more control with the interact. For example, in here, what we're doing is saying do all that automatic logic of creating controls, etc., but don't display it because I might want to change it a little bit here. And so I've asked you to investigate the function, create controls based on these hints, but don't display it just yet. In fact, what's given back is an object, this W object, that has a couple of children. Here's the 2 controls, and here's the output widget. The output widget is the thing that contains the output of the function. We can actually display it, or we can modify it if we'd like. We could put another control in there. We can change how they're displayed, etc. One nice thing about using this interactive instead of interact is it gives you some value, the current values of the controls and the keyword arguments and the actual result given by the function. Sometimes if you're working with a function, you have a function that runs a little bit slower, and so you don't want to update the function every single time control is changed. So here we have a slow function, and you can see it takes about a half second. And in this case, what we're going to do is we're going to well, if I see, as I change the value, the function takes some time to run. So often if you're plotting something or doing a complicated calculation, this is kind of a bad user experience because the output's constantly dragging and there's too many outputs as I'm just scrolling over parameter space. So there's a couple of ways we can deal with this. The interact manual function changes the controls to have a special button that will take the current parameters and run the function. So you can adjust all the parameters like you like and then press the run interact button. Or we can just say, create the float slider by ourselves and say continuous update equals false. So this is an option to the float slider that says, don't notify anybody that I've changed until you let off as a slider. So here I'm scrolling in the parameter space for this slider, nothing's happening, and things happen when I let off of the slider. We could do a little bit trickier things, and for example, we can hook 2 sliders up to each other so that one depends on the other. Here's I have a X slider that goes from 0 to 10, and a Y slider that's going to adjust the top value of the X slider. So I have one control here, and the second control is changing the parameter space, the range for the first control. And finally, sometimes if you have a plot specifically or other output that takes a bunch of space, seeing the output disappear and appear can be distracting sometimes. And so there's ways to fix the height of the output so that the height stays the same. You don't have any flickering with the output disappearing and reappearing. So these are sort of more manual things that you can do to make the interactive experience a little bit nicer. But first, why don't we take a few seconds? Any questions about using interact?
Yeah, and everybody's, guys, you're muted here. I'll unmute everybody for a second. Okay, anybody have any questions?
Okay.
I was just going to say, yeah, go ahead.
Go ahead. I was going to say, is there a way to take a short survey with like I'm not sure in GoToMeeting if there's a way to take a short survey of if people have used interact, if people have used widgets, if people have used the notebook?
I'm not sure.
If there's not, that's fine. Okay.
Yeah, I know that some of the people on this call have, but I've already learned a couple things that I didn't
Oh,
know
great.
about. I know about particularly about things that take a while, or that you don't want to have it being updated all the time and stuff. So that's great.
Yeah. Well, the chat's open, and I assume Rich is monitoring the chat. So if you have any questions, feel free to type in a question, and Rich can interrupt and ask the question. The basic usage of interact is actually fairly simple, but there's enough parameters, enough knobs that you can tweak that it actually goes quite a ways to solving issues with being able to easily and quickly interact with a function. But let's move on from interact and go into the widget. So we saw a little bit of an introduction to the widgets here when we were creating our own float sliders and int sliders and things like that. And we called each of these user controls a widget. And you can think about the Jupyter Widgets project in two basic ways. You can think about it as a way to build an interactive GUI for your notebooks or for your functions, for your calculations. But it's actually a lot more powerful than that. Jupyter Widgets is also a framework for building complex interactions with the browser and some sort of kernel side state, some sort of computation or data that's living inside the kernel. First, we'll talk a lot more about building interactive GUIs for your notebooks, and then we'll have some examples, show you some examples of people that have taken ipywidgets not just as a set of controls, but as a framework for working with interactive controls in the notebook, and have done some pretty amazing stuff. So first, if I wanted to build a GUI, some sort of interactive graphical user interface inside of a notebook, the widgets has you covered in that it has a list of common controls that people can use. So for example, if you want a slider, here's a slider, widgets.int slider. This creates the slider and displays it. You can explicitly create the slider and explicitly display it using the IPython display functions. And in fact, you can display the slider more than once. So these two sliders right here are exactly the same slider. We're just displaying two instances, two controls that represent this W slider. And you'll notice that they're the exact same slider. As I drag one, you see the other one updates as well. And the same on the other way. And the reason for this is and something fundamental about the architecture of widgets that is really good to keep in mind is we're really talking about syncing values between the kernel and the front end, and then displaying those values in whatever cells or whatever fashion that you want. So the basic architecture for ipywidgets is we have some kernel side object. Can you see my cursor if I'm pointing?
Yes.
Okay. So we have some kernel side object. And it represents the value, and it has other things like the min and the max, etc. And that's automatically communicating between the kernel, which is your Python side, and your browser, which is JavaScript or HTML, another object on the browser side that also has the notion of the value of the widget, the min and the max, etc., and various attributes of the widget. So these you don't see. They just happen and sync their values back and forth automatically. What you actually see is the widget views, and you can have multiple views of the same underlying model. So you can have multiple views of the same underlying control. And that's what we were seeing up here, that we had two different views of the same underlying object representing a slider value. And each of these views is automatically updated. And as I change any one of these views, it automatically is communicating that change back to the browser model, which is then automatically syncing that change back to Python. And the cool thing about this, and the sort of the genius of what this allows you to do, is now I get to do anything I want based on this value in Python side changing. So for example, if I change the slider, I can automatically have a Python function that runs with that new value. I don't have to execute a cell. I don't have to do anything about it. I can set it up so that anytime that slider value changes, that value is automatically communicated back to the Python side, and I can run a function based on that new value back here. And that's sort of the core of this user, this interactive controls. And it's very different from most things in the notebook where you execute something in the Python side and it's displayed in the front end. And often you can even interact with things in the front end, but values aren't communicated back to the Python side. And more than just communicating back to the Python side, if I change something in the Python side, it automatically updates the things in the front end side. So for example, let's see, I guess 2 more examples. You can also close a widget, and that gets rid of the widget. But these widget properties. Okay, so you see here that I've asked what the value of the widget is. I've displayed the widget. If I change this widget, that changes automatically, that new value is automatically communicated back to Python. And so if I rerun this cell and ask, now what's the value of the widget? It's 45. And if I change the value in the Python side, it automatically communicates that change to the front end and updates all of my views, all of the controls that I've displayed, and I see the new value. So we really have this interaction between front-end control and my Python code. There's a number of attributes that are synced back and forth. If you ever want to see all the attributes that are synced back and forth, you can use the .keys attribute of any widget. Ignore the ones that start with underscores. Those are ones that are sort of internal bookkeeping stuff. And then the ones that don't start with underscores are typically things that the user can change. And so here we have a value, min and max, whether that was a continuous update like we saw before, and various other attributes. And we can set these attributes when we actually create the widget. So for example, here's a text widget, and I'm setting the value immediately, and I'm setting this widget to be disabled, so I can't change the widget. I can also link together 2 widgets. So in this example, what I have is 2 widgets, a float text and a float slider. I've displayed both of them. So now I see the views of those widgets. And I've used this new function, this JS link function. What it does is it says, anytime A's value attribute changes, sync it with B's value attribute, and vice versa. Make these 2 value attributes correspond to each other. And so as I change A's value attribute, you can see B's is, or let's see, I guess this is B's value attribute. A's is automatically changing. And if I change A's attribute, B's automatically changes. So it's very easy to have these widgets interact with each other as well. Yeah, question?
So that's different than when you showed us the 2 sliders where the bottom slider was basically changing the limits for the upper slider?
That's right. That's right. Up here, let's scroll back up to where that was. Up here, these were actually the same underlying model. They're automatically always synced together.
Right. I was thinking of the other where you had the lower slider was, you know, on your earlier.
Yes, on the interact example, I think it was well, down here somewhere, down at the very end, right here.
Yeah.
Yeah. So this is very similar. This is a bit more manual process. What this did is it said, anytime the Y value changes, that observe Y value changes. And anytime that Y value changes, run this Python function, update X range, which changes the X value maximum.
Okay, but you could have done it with the JS link, I guess.
The JS link is a shortcut for when you want the change to not have any calculation. Here, I changed the X to be 2 times the Y value. If I was changing it to be the actual Y value, then I could have used the link.
Okay.
And I could have linked up the value of one to the maximum of the other. So this is a shortcut method that automatically listens for changes on one of the widgets and sets the value on the other, and vice versa.
Okay, thanks.
And then it's easy to unlink those widgets as well. So some shortcuts here for taking our interactive controls and linking them together. Okay, so next let's look at these events. So again, one of the big things with widgets is that I can be notified anytime the widget changes, and I can run code based on that. And the way to do this is through several functions. The button has a special function called the onClick function, and it basically, anytime the button is clicked, you can set this function to be run. So click me. And every time it clicks, it's printing out button clicked. The more common way to interact with widget value changes is using the observe function. So So here's the documentation for the observe function. You can read it later for details, but basically the idea is in this code right here. So here I have, I'm creating an int slider and I'm displaying it. I'm creating a new function on value change, and then I'm saying anytime this slider changes, so this is the observe function, observe the changes in the value attribute, and when the value attribute changes, run this function here. And so what you'll see is, as the slider is changing, that function, which is printing the new value, is being run, and we see the output here. It can get quite long, of course. So again, the genius here is, the key thing here is, anytime my widget changes, I can run an arbitrary Python function, and this is the powerful thing with the widgets. Here's the linking as well. We're spending a lot of time on this stuff, so I won't run these functions. And a bunch of other documentation about how that linking works, that automatically changes one value based on another. It keeps two values of widgets in sync with each other. Let's look at a list of what kinds of controls Jupyter Widgets comes with by default. So there's a variety of controls, an int slider, and here we have a listing of some of the attributes and some of the values that you can see that you can set, a min and max, as well as a description, which is this label off to the left. Things like whether the value is displayed to the right, what the format of the value is, etc. The float slider is similar, but with float values. We can display the sliders vertically using this orientation argument. We can have a range slider that gives us back two values. You can see here, if we set this to be, we save the value of this, and we can see that the value here is the min and the maximum of the range. And the same thing for floats. So float value. We can have a progress bar, again with a bunch of attributes, and a float progress. We could have inputs that are textual inputs. So here's an integer value. It works well with the browser integer text control, and same thing with floats. Those are bounded. I have a min and a max for them, or I can just leave it unbounded. Here's an integer. It'll take any integer, and same for floats. For Boolean values, we can have a toggle button that you can toggle on and off, standard checkbox, and then a notification widget. This is just the notification that you can put somewhere saying the value is invalid or the value is valid. We also have a complement of selection widgets. So here's a dropdown. You probably won't see the choices in the dropdown because GoToMeeting is not capturing the choices. But if you run the example, you'll see it's a standard dropdown in your operating system.
Jason, is this? I'm just a little curious about the why we are not seeing this. Is that because you shared just a browser window instead of your desktop?
I wonder if that would change things. Here, let me try sharing my entire desktop. Let's see, how do I unshare and share again?
I think you can, if you should be able to just click your the share screen, share your screen to unclick it, and then click it again. It should hopefully give you the choices again.
A choice. Did I unshare and share?
Yeah. Okay. Never mind. We're just back there again.
Never mind. I see where it is. Yep. Here, let me see if that helps. All right. So it should be sharing my whole screen.
Hey, can you see it? There we go. Yes.
There you go.
Now we can. Now
okay.
We can okay. Okay. Good.
So it is a drop down.
Okay.
You also have other selection widgets like radio buttons, an actual select box, a selection slider that lets you slide through values, and a selection range slider. So this is an easy way to get like a range of dates or something like this. You have toggle buttons that let you choose between values. You have multiple selections as well. This is a standard multiple selection. So a variety of ways to provide a set of values to the user and let them select. And text widgets. So we have a standard sort of single text box, or we have a bigger text area box. And you can make the text area box bigger by setting the rows attribute, for example. Here's 10 rows allowed. We have a display widget, which is this label widget. Mathematics is interpreted. So here what we've done is we've used a label widget right next to a float slider to give us sort of a fancy label. And we have an HTML widget. This is actually pretty powerful. What it does is it lets you very easily display rich output to the user. You have one control that's changing. It's going to trigger some computation. You generate some HTML from this computation, and then you set the value of the HTML widget. So for example, here, and then I think the widget value, and what I can do is just change the value, and you see the new value is updated here.
Oh, so that's so in general, like, usually we just do our rich text in Markdown, but this gives you programmatic ability to drive your rich text, I guess, or more than that, right?
That's right. That's right.
Okay.
And there'll be even, in just a second, we'll see even another way to do this as well. We also have HTML math, an image widget that lets you change the image. Again, any one of these sort of display widgets, often they're used to display some computation, some result, et cetera, for the user, but then it's very easy to change that. Here you can just easily change the source of the image, and it updates in place, in line. Of course, we've seen the button widget. The output widget actually is one of the more powerful widgets here. What the output widget does is it actually captures the output of whatever code that you're running here. So I've displayed the output widget here. You don't see it because it's empty. But if I use that output widget, I use it as a context manager, and I run some code inside of this context of the output widget, what you'll see is that that output is captured, not displayed below this cell, but it's captured and displayed inside of that output widget. And so what this allows you to do is very easily set up a user interface and run some code and capture the output of that code. And that output could contain images, it could contain plots, it could contain rich text, et cetera. And that output will appear inside the output widget in whatever interface that you've designed here. And even rich output. So for example, here I'm displaying a video inside of this output widget. And again, the video is not displayed in this cell. Instead, that output is captured and displayed in this output widget that I've displayed up here. So this is actually how interact works. It runs your function in the context of an output widget, and then as you run the function, the output widget is updated with the new output. We'll see one or two more examples of this output widget in a few minutes. The play widget just provides a control that automatically increments its values. What we've done here is we've created a play control. It has standard controls, and what it does is it will increment its value over time. And what we've done is link that play control to the slider value. And so as I play, it's changing its value, and the link is automatically updating the slider control value. And so I end up with an animation. I can make an animation pretty easily from this. We've got a date picker control. This is a standard browser date picker control, standard browser color picker control. One of the very interesting things about ipywidgets is that it not only allows you to have controls that let the user input, but it lets you basically access anything that the browser can consider as an input source. And so, for example, the browser has a game controller API that lets you hook up like an Xbox game controller. And what we've done, what Sylvan Corley did here was he wrote a widget that lets you hook up an Xbox controller or a game controller to your computer that will then talk to your browser. And you can then control your Python code with your Xbox controller. There's a great video online of him showing how to do a flight simulator in a couple dozen lines of code that's controlled by an Xbox controller, all using the ipywidgets framework.
Oh, cool.
It's actually a really fun video. I could get the link for you later. There's a lot of the controls deal with designing UIs, and so we need ways to lay out widgets. So you have a basic horizontal box or vertical box that lays the widgets out horizontally or vertically. And we have a few other container widgets like an accordion widget that lets you provide a number of different panels to the user, and they can select one of them, or a tab widget that provides, again, a tab interface, and the user can select a page of controls if they want. So a huge complement of controls for building simple user interfaces for your computations, but that's not all that ipywidgets offers. This is scratching the surface of what ipywidgets offers. This is the controls that ipywidgets comes with, but even beyond this, we have a huge and growing ecosystem of third-party controls that rely on this underlying framework of ipywidgets. This underlying framework of ipywidgets of having some rich control that's automatically syncing its value back and forth to the Python side. And so changes in Python affect the control, changes in the control affect Python. And so I think with the time, I want to show you some demos of some more advanced third-party controls. But I recommend that you, if you're interested in this or seeing the capabilities of this a little bit more, to look at the documentation. You can also download the documentation as notebooks that you can execute like we're doing here. In particular, there's a lot more documentation on laying out widgets and changing their styles, so putting a box around them. Let me just execute a little bit of code. You can change heights and widths of buttons. You can change just, sometimes the label's too small, so it's easy to change the width of that label. There's things like laying out buttons, with an HBox or VBox. There's a big tutorial here about laying out things using a browser technology called Flexbox that we expose with ipywidgets. But in the end result, you have a flexible system for laying out widgets. Here's a more complicated widget layout where I have a slider, a drop down, some text boxes all arranged in a vertical stacking. Here's a little more here we have a horizontal scrolling list of boxes. And for a particular control, we can also change things like the color of the buttons, various other things about the style like the font weight. For example, the end slider, we can change the color of the handle. So each control can have a number of tweaks to its visual appearance, as well as stacking these controls together to make a pretty powerful UI system. Before I go to third-party widgets and some of the capabilities that are being enabled by people writing custom widgets, any questions about sort of the basic widgets, the framework, the controls that are provided by default?
These are all just the standard stuff you would get if you just said like conda install ipywidgets?
That's right.
Okay.
So all of this comes in the base ipywidgets package.
Okay.
All right, so let me show some demos. And for these demos, I'm actually going to switch to Jupyter Lab. Some demos. So I think you've all seen Jupyter Lab if you were in some of the previous meetings. Essentially, Jupyter Lab is the next generation notebook, but it's far more than just a notebook. It's an entire IDE like environment in your web browser. So I'm going to close some of these that I was playing with before, and I'm going to show two specific libraries, ipyleaflet as a nod to the geoscience community here, and bqplot, which is an advanced plotting library that's based on the ipywidgets framework. So first, ipyleaflet. So what ipyleaflet does is it provides, so I'm going to open up a notebook and execute it. What it does is it provides an interactive map using leaflet inside of the notebook. And there's various libraries that provide sort of interactive maps inside of the notebook. But because ipyleaflet's built on top of the widgets infrastructure, you get the interactivity that you're missing in a lot of other libraries. So for example, here's an example of a map. Okay, and I'm going to actually use an advanced feature that Jupyter Lab provides in the newest release that came out this morning. And that is this create new view for cell. And this is a powerful capability for widgets particularly. What it does is it creates a copy of the cell in a new tab. And so I can drag this new tab down. Let me collapse that, give us a little more space. And so what I see is, here's the full notebook up here. And here is just that cell, just a copy of that cell down here. So I'll run that cell, and I see just a copy of this cell down here. I'm going to even collapse the input. And so what we can do is work with the widgets up in the notebook, and you'll see how it affects the cell down here. So for example, the zoom level, here's, again, some of the interaction between the interactive control and the Python side. Here the zoom level set to 10, and I believe I can just change the zoom level, and automatically the zoom level, automatically that particular widget updates. And again, you see it updating here in the notebook, but you also see it updating down here in my copy of that cell up there. So, so we have draw controls in Leaflet. So let's go ahead and add one. And you'll see, again, just to emphasize, they were added in line in that leaflet that was displayed in that cell up here, but a copy of that cell is down here, so we don't have to keep scrolling back up to that to the cell above us. We just see the copy of exactly what's happening here, right here. So in this draw control, I have, of course, a number of options. For example, I can draw a circle marker here. Let's see if I remember how to do this. So I've drawn some sort of shape on the map, and I can, and as I draw that shape, those changes are being communicated back to Python. This is the interactive part. So I can ask draw control, what's the last action that happened? Oh, something was created. Okay, give me that last draw. And here's the shape that I drew. And so I can run Python code in real time as the user's clicking and changing a shape on the map. And that's the interactive part of ipyleaflet. Here's a second map. And we can import GeoJSON data. So I'm going to close this cell and clone, or maybe we don't need to clone this cell. It's only a few cells here. I've zoomed and I've panned it. Again, I've taken control of the map. In line, it's updating based on how I've written the Python code. And I'm going to make, let's see, a new polygon based on that shape that I drew. And if we're in luck, yep, I see that shape that I drew on the other map. I've pulled that shape, that data back to Python, and I've added that shape to a new map. And here I can change a few other parameters. So we've changed the draw control that's enabled. So again, the cool thing here is there's complete interactive activity between the Python side and the JavaScript side here.
So can I ask a question?
Yeah.
So if you were, let's say you you had this map and you had some, like you had some winds measured at airports or something like that, and you could add those markers to this map, right? And then you could have the user click on a marker and then pop up, say, a time series or something, or maybe not. I guess would that be they could pop up a time series, but that would be in a different cell, obviously, right?
Well, what you could do is you could have, in fact, there's an example of this sort of thing. You could have a separate plot over here using like bqplot library. And as you click on this, it automatically communicates the changes back to Python. Python computes a new value for the graph and updates the graph, and then the graph changes over here.
Ah, cool.
So for example, I'll show you a screenshot of a 24-hour hackathon that the Bloomberg quants went to in San Francisco. Here we have ipyleaflet and a ipywidgets control here, and the two are hooked up so that as you change an ipywidgets dropdown here, it's communicating back to the Python code, and the Python code is updating the leaflet map. Here's an example that's more in line with what you were saying. Here I have an ipyleaflet control to the left and a bqplot chart to the right. bqplot is an advanced plotting library built on the ipywidgets framework. So again, you get all the interactivity. You can tweak a plot and it updates inline, etc. And so what's happening here is you choose, I think, a zip code region in ipyleaflet, and that change, that click is being communicated back to Python. The Python's pulling some values out or doing some computations and updating the chart in Python, and then those values are automatically being synced back to the front end, and the chart is updated over here. So yeah, this is, I think, exactly what you were talking about.
That is exactly, yes.
And so then you can create a, using this new feature of Jupyter Lab, this create new view for cell, and you essentially have the basics of a dashboard because you just see the output of this particular cell. You don't see the rest of the notebook. So some very powerful things and things that are being even developed as we speak. The ipyleaflet has a number of primitives. I think a lot of people here are familiar with the sorts of things you would do on a map. So you can zoom. In fact, one nice thing about ipyleaflet, it has this interact function that automatically creates a control that controls a value for the map. So here I've created easily a control for a parameter on the map. I can add layers, remove layers. I can see the values of various attributes of the map. I can create a marker here. Let me create a new view for this cell. And I'll run it again. There we go. So let's see. So here I've created a marker right here. Looks like the image may not be loading for some reason. I can create an image overlay. I can remove that image overlay. And again, this is updating my plot inline, and I'm just looking at a copy of it here. I can create a polyline. So this is a line for the map boundaries. I can change its fill color, opacity. I can take it back off. There's a polygon. Again, that's just the map boundaries. I can take it off. A rectangle. I can add a circle. I've added a circle right there in the center. I can create some controls that change the opacity and the weight of that circle very easily. I can investigate the layers, etc. Here's a circle marker. I can take it back off, multiple circles, etc. So I can interact with maps very easily and have those interactions run arbitrary Python code that then update other things or change the map in some way, etc. Very powerful thing. And again, the key here is that we're going back to this underlying architecture. ipyleaflet is a third-party library, so it's a separate package you install, but it's built on the framework of the ipywidgets ecosystem, where it uses ipyleaflet for this view layer, and it has a number of attributes that are synced back and forth automatically with the Python and JavaScript side. As you change the view layer, those attributes get automatically synced back to Python. We can run whatever code we want. We can change a value, and that's automatically synced back to the views that we see.
Awesome.
I realize we're running a little bit short on time. Maybe I'll just show one example from bqplot, and we can wrap up this segment here. Or maybe two examples. One that shows the basic plotting. So bqplot is a plotting library that's built on the ipywidgets framework, and at least part of the API, this pyplot API here, was designed to be very similar to the matplotlib API. So here's a figure. I want to plot X and Y time series or X and Y data, and show a label and show the plot. And so we get sort of pretty standard plots, but you notice that what happened there is I can update things inline. So I'm going to create that plot. See, there's the plot right there. And here I'm just going to change the Y label. I'm going to set the title for the figure. You'll notice that set the title up here. And so we have it sort of an interactive thing. It's not just interaction like that. We can also interactively pick values in the plot. So for example, here's a bunch of setup code. And so we have a chart, and we want to very easily pick a range inside the chart. And so we have something we call a fast interval selector. The y-coordinate determines the width of the selection, the x-coordinate determines the center of the selection, and what you're seeing right above this plot right here is a real-time update from Python on what was selected. So as I scroll over the chart, my Python code is being run, and in this case, it's just updating a display of what was actually selected. But of course, as you scroll over the chart, you can easily update a map, you can easily update another chart, you can run some computation, etc. You can do the same thing for selecting a specific value here. So again, as I'm scrolling over the chart, the Python sites get notified of the thing that I'm actually hovering over. And let me just, I'm going to execute pretty much the entire notebook just to get down to the very, very bottom. And these example notebooks are on the bqplot tutorial. So here I have basically a chart that's somewhat complicated. It's got several different values, several different axes, etc., and the interactions. Here I have that fast interval selection action, and you can see my Python code's getting called and the value is being updated up at the top. I've got the index selector. I can brush out a selection. I can brush out multiple selections. If I hold Shift, I think, or Control, there's a way to brush out multiple selections. I can even change my data. So here, as I'm drawing on the chart, it's actually communicating that data change back to Python and changing the NumPy array that represents that data. Or I can change my other data. So this lets you easily draw what-if scenarios. Heaven forbid that it's used for academic integrity issues. but the point here is I have full interaction, and it's running arbitrary Python code with however I've interacted with this chart. So this is a library that was designed and by Bloomberg Quants and then open sourced just a year or two ago. And it's very powerful, and again, built on the top of the ipywidgets framework. So you can use the rest of the ipywidgets controls, you can link up events, etc., pretty fluidly between this and any other sort of widget.
And does bqplot have a hover? Like, can you hover over a line and get a value and stuff like that if you want? Yeah.
Yeah. In fact, I'll show you probably a very familiar example. Here's a pretty small notebook, all things considered, that reproduces the Wealth of Nations example. So again, I have an ipywidgets animate control. It's hooked up to the slider control. I could just change the slider. As I'm changing the slider, this value, automatically Python code is being called, which then updates the bqplot Python object, which then communicates its value back and re-renders. If I hover over it, I see the actual data for that particular point plus the path that point's going to travel. Yeah, very powerful plotting framework.
Great.
And cool. Built on top of the ipywidgets ecosystem so that it very naturally interacts with all the rest of the controls that are there.
Mm-hmm. Cool.
And I'll show you one other page. All of these controls work inside the notebook, but they also work outside of the notebook. So here on the Jupyter.org webpage, this is a standard Jupyter.org webpage, we have some examples of using these controls on a standard webpage. So here's the ipyleaflet, here's bqplot, but here's a few other libraries. For example, there's a library that does 3D rendering of objects using a 3D scene graph. There's a library that does higher level 3D plotting. Here, I'm looking at a 3D vector field.
Wait,
animating it through time.
Are you interacting with Python here?
This is actually all on a web page. It's not interacting with Python.
Okay.
But it's very easy to interact with Python. It's very easy to set up these controls on a web page. If you can get to a Python kernel somewhere, if you can somehow provide a Python kernel to the web page, it's very easy to, it requires a little bit of work, but it's pretty straightforward to hook up a widget UI to a Python kernel outside of the notebook and have yourself really a nice little dashboard.
Okay.
And here's one more control that's a grid control that BeakerX has open sourced recently. So lots of capabilities. There's a lot of capabilities inside of the stock ipywidgets, Jupyter Widgets package for doing basic and standard sort of UIs. It's sort of as complicated as you want with standard controls. But the more exciting thing, I think, is the underlying framework that enables third-party packages, packages that you install on top of ipywidgets that do all sorts of things from plotting to mapping to 3D visualization to grids, etc. And then they all fluidly work together. You can have changes in one, trigger changes in the other, etc.
Cool. I'm not, I mean, there may be some people who drop off in 2 minutes, but I think because we're recording this, if you have something additional cool to show, or if Chris had something to show, we could keep rolling for a little bit.
Yeah, in particular, Chris Keys has been using widgets quite a bit. Chris, do you have a couple of words on how you've been using widgets, and especially in the geoscience community?
And do you want me to make you the presenter, Chris?
No, I didn't prepare anything to present. I'm sorry, I don't have any nice, cool examples to put up at the moment. I can talk a little bit real quick about the kind of things that we've done. We're primarily interested in, well, not primarily, but one of my main interests is in driving simulations, either 2D storm surge or flooding simulations based on things like the shallow water equations, or 3D simulations of some of our physical modeling facilities like wave basins and hydraulic flumes. And so that's kind of how part of the way that we got involved is trying to develop a demonstration application where a planner could go and draw a domain of interest and then do a coupled wave and storm surge calculation. And that's where the ipyleaflet tool kind of got started, as we were working with Brian Granger, and he kind of kicked off the development of that tool. So that's part of the reason why it has drawing tools in it, is that you can draw polygons and things like that and then extract that geometry. And then we had workflows built on top of that where we would mesh that region and do some data assimilation for various sources of bathymetry and offshore wave information to drive a simulation. And then kind of more recently, I've started developing something called ipymesh, which is really in its infancy, but it's kind of a version, something that has some similar drawing tools to ipyleaflet, but it's really more focused on drawing on top of images or engineering diagrams, and kind of for some of those wave tank applications that I mentioned earlier. So I guess other than that, I can't think of anything that would be really up to date. I mean, we had developed a sort of almost a live poster. It was a large format IPython notebook that had all of the code stripped out so that everything was controlled by widgets. And some of the stuff that Jason just showed, where you're building web pages, from your Jupyter notebooks, is kind of I think the next generation of that type of approach, where you do all your work that might involve a fair amount of coding and technical things, but then at the end of the day, you want to strip away a lot of the complexity and provide just the controls that decision makers or other users would require. And so those capabilities are really evolving independently in the Jupyter and Jupyter Lab ecosystem.
Okay. Yeah, actually, we want to do, we're interested in doing very similar things, so we'll be in touch. Jason, did you had one more thing you were going to show, which was a pretty cool demo that from the JRC guys. Did you want to show that? I lost your audio, looks like.
I think I muted myself.
Oh, there you go.
Right.
Okay. Yeah.
Maybe could we turn off the recording?
Yep. Fantastic. Does anybody have any other questions for Jason before we close this out?
Yeah, this is Roy. Do the widgets only work with Python, or do they work with other languages supported by Jupyter Lab?
They work with other languages as well. There's nothing Python specific about it. It's just that the kernel side of the widgets needs to be implemented for that other language. So there have been people that have worked is there a language that you're thinking of particularly?
Yeah, R.
Yeah, so R has seen some development, but probably the most exciting thing in that area is Sylvain Corley, who I've mentioned a couple of times, has implemented basically all of the widgets in C++. And so what you end up seeing from that is any language kernel that can be written using his C++ kernel automatically gets all of the widget framework for free. And so there's work on implementing a new R kernel that uses his C++ framework, and that should give you widgets sort of automatically. You might have to build some sort of language specific framework around it to make it natural inside of that language. But there's nothing specific about Python in the widgets other than that's the implementation we wrote as a reference implementation.
Okay, because it'd be nice to actually be able to mix languages in a notebook and have the widgets control both. Of course, there are advantages to using R in some cases and advantages to using Python in some cases.
Yeah, that's mixing languages is a bit tricky in the notebook because state in the kernel is often not shared. If you have two different languages in the same notebook, then the variables in one language are not shared with the variable workspace in the other language. There are some projects like Beaker and some other projects for trying to have this sort of sharing of state between the kernels. But yeah, I think that's an interesting and fascinating topic, and people are working on it.
Beaker's pretty much going underneath the Jupyter Lab thing now, right? They've pretty much stopped their own development, if I understand.
They are still doing a lot of development, but the development is geared towards customizing Jupyter Notebook and eventually customizing Jupyter Lab. So a lot of their development is now sort of joined forces with us in the Jupyter Notebook, Jupyter Lab project. But I don't want to speak too much for them. I'd let them speak for themselves. But their new version is a customized layer on top of the Jupyter Notebook, and they're working heavily with us in widgets and in Jupyter Lab as well.
Okay, thank you.
Hey, this is Chris Keys. Just one thing on the last comment too, though, is that as long as you're willing to let one language kind of be the glue and kind of run the show, it is really easy to incorporate other code written in other languages that does specific things. So I know that some of these newer efforts are more seamless than that, but even when we were doing our initial work, we were pulling in people's MATLAB code via some Python MATLAB bindings, and using Fortran and C++ and stuff like that. And the decision was that we're just going to let Python be the thing that binds all this stuff together. And it that worked reasonably well, but it doesn't put the languages on an equal footing, which is what I think people would really like. But anyway, just my 2 cents on that, especially working in a large organization where you've got lots of legacy code and definitely there are the right tools for the job in many cases, and you want to stick with that language. But sometimes when you're developing something like a web application, you can go ahead and make the decision that, well, we're going to do all of the binding together in Python, and that gives you a way forward.
That is a good point. And so the widgets basically work from Python, and then Python calls out to another language to do specific computations.
All right. Anybody else? All right. Well, I'd just like to thank Jason again. That was really a nice, clear presentation. I'm sure it'll get lots of views by folks in the community over the upcoming weeks and months. And thanks, Chris, also for a cameo. It's good to see the core here. Please show up again. Yeah. Maybe we'll get you guys to give a presentation on an upcoming tech dive on what you're up to and dive in a little deeper. All right, thanks everybody. I'll see you in a month.
Yep, and you're welcome to email me or hop on the Getter for ipywidgets, et cetera, if you have any questions. There's quite a few people working on widgets, and we're eager to answer questions and help people.
Okay, great. All right, thanks again. See you, everybody.
Thank you.
Thank you.